In this video, we're going to be taking a look at special right triangles. Special right triangles have patterns that we can follow to find missing sides, so we don't actually have to rely on SOHCAHTOA. There's two types, a 45-45-90 and a 30-60-90. Let's take a look at our 45-45-90 triangle first. This is an isosceles right triangle. When you have two equal angles, you would also have two equal sides. So let's just explore why this works by just saying that both sides are 5 and see what happens. We can solve for the hypotenuse, which we'll just call n, by using Pythagorean theorem. So we end up with 25 plus 25 equals n squared. 50 is n squared, so n is radical 50. You can't see the pattern with that. But if we simplify this, we get radical 25 times radical 2. And as soon as we do one more step, we get 5 radical 2. That's the pattern that we're going to have. So check out this pattern. We have 5, 5, 5 radical 2. Let's come up with the pattern for any 45-45-90 triangle. So let's call the bottom side N. Are you ready? It's a mathematical motto. I want to make sure you're ready. Here it is. Show me the pattern. Does it make you feel good to say it? Show me the pattern. Show me the pattern. No, not show you the pattern. Show me the pattern. Show me the pattern. I love trigonometry. All right, let's try this out on some other ones. First of all, how do you know for certain that you have a 45-45-90 triangle? They don't have to give you all the angles. If they simply show you that you have an isosceles triangle that's right angle, those would have to be 45-45-90. Also, if they gave you just one 45 degree and one right angle, you could use triangle equals 180 to prove that the other side is 45. If they gave us two 45 degree angles, the third missing side using triangle equals 180 would have to be a right angle. So they don't have to give you all the complete angles to know that you have a 45-45-90 triangle. All right, let's practice some. So what if I give you just one side? I tell you that side is 8. Show me the pattern. 8, 8, 8 radical 2. Let's try another one. What if I tell you the side is 27? Show me the pattern. 27, 27, 27 radical 2. This is getting easy. Let's try another one. What if I say 89's over there on the right side for one of the legs? Show me the pattern. 89, 89, and 89 radical 2 for your hypotenuse. Now, there's two ways that we can make this difficult. Help me to help you. So pay close attention to this. What if I show you that the hypotenuse is 10? This is not going to be an easy problem because we'd rather see a 10 radical 2, but we just have a 10. But let's move this up smaller so we can work on it. Let's call that leg N. And if we follow the pattern, the legs are N. And then notice that the 10 is where we have the N radical 2 part of the pattern. So we just have to let N radical 2 equal 10. So now let's solve that. Divide both sides by radical 2. And we get 10 divided by radical 2, which we want to simplify because we don't want radicals on the bottom. So multiply both sides by radical 2. We're left with 10 radical 2 over 2. And you can actually reduce that 10 and that 2 and get a final answer of 5 radical 2. So in this situation, 5 radical 2 would be the two missing sides that are legs. All right, let's try another one that's difficult. Go ahead and, if you want, pause the video and try this one on your own. All right, so once again, we don't have what we'd like to have. we have a whole number for our hypotenuse. There's no radical 2. So the other legs can be n. That means 7 is equal to n radical 2. And we can set that up, divide both sides by radical 2, and then we just have to, they cancel out. We have to go ahead and simplify our 7 divided by radical 2, multiply by radical 2 over radical 2, and we get 7 radical 2 over 2. This time we can't simplify the 7 and 2, so that is the length of both of your legs. All right, I told you there was 2 things we can do to make this more difficult. So the first one is to give you the whole number when you expect a radical 2. The second way to make special right triangles difficult is to give you a second pattern. So let's take a look at our 30, 60, 90. Now once you have a second pattern, then sometimes you can mix and match them and mess them up. So let's pretend that our short leg on this 30, 60, 90 is 5. So let's use SOHCAHTOA to find the hypotenuse, which we'll say is x. So we have our hypotenuse opposite from the, we're going to choose the 30 degrees, and then we have our adjacent over there that we're not going to use. So we have O and H, so we're going to use sine, so, and let's set it up. Sine of 30 degrees equals 5 over x. Multiply both sides by x. And then divide both sides by sine of 30. We get our exact answer, which is 5 divided by sine of 30 degrees. When you do this on the calculator, you get x equals 10. So our hypotenuse in this is 10. So now let's go ahead and see how we get the third side. And we don't want to use SOHCAHTOA for this. It won't show the pattern. So we're going to rely on Pythagorean theorem to find our long leg, which we can call x. So we have our hypotenuse. The other 2 sides are legs. So there's our x squared plus 5 squared equals 10 squared. And we simplify this down, subtract our 25, we get x squared equals 75. So x is radical 75. And again, you're not going to see the pattern until you simplify this. So this becomes radical 25 times radical 3. And then when we simplify the radical 25, we get 5 radical 3. So let's replace our x with 5 radical 3 and see if we can discover the pattern here. If we want our short leg to be n, what do we do to the 5 on the short leg to get to 10 on the hypotenuse? We multiply by 2. So that means our hypotenuse is 2n. What do we do to the 5 to get 5 radical 3 for our long leg? We multiply by radical 3. So if you have n for your short leg, your long leg is n radical 3. So that is our pattern for 30, 60, 90 triangles. Let's go ahead and practice a few. What if I tell you the short leg is 12? Then that means the hypotenuse would be double that, 2 times n, it would be 24. And our long leg would be 12 radical 3, because we're going n radical 3 to get the long leg. All right, let's try another one. What if I give you the hypotenuse is 40? So if 2n equals 40, that means n would be just 20. So our short leg is 20. Once you have the short leg, it's easy to find the long leg by just multiplying by radical 3. So the long leg is 20 radical 3. Try another one. All right, if you want to give this one a try, go ahead. All right, this time you're given the long leg, and it is in the form that we like to see. The long leg is 17 radical 3. So if the long leg's 17 radical 3, that means the short leg is simply 17. And then to get the hypotenuse, take the 17 and double it and get 34. All right, last one. This is the difficult one that takes a little more extra effort. Because we have a 15 for the long leg, we would like to see a radical 3, but we don't have it. But we do know that the 15 is equal to n radical 3 in our pattern. And let's make that triangle smaller and go ahead and solve for it. So we know n radical 3 is 15. Divide both sides by radical 3. And they cancel out. We get n is 15 divided by radical 3. multiply by radical 3 over radical 3 to simplify the radical, and we're left with 15 radical 3 over 3, and this time the 15 and the 3 can reduce to 5 radical 3. So 5 radical 3 would be our short leg, and then to find our hypotenuse, we're going to go ahead and just double it, and that would give us 10 radical 3 for our hypotenuse. Now, before we move on, let's just double check that this worked out. If our short leg is 5 radical 3, that means we should multiply it by radical 3 to get the long leg. So in other words, 5 radical 3 times radical 3 needs to give us 15. Does it? Well, radical 3 times radical 3 is just 3, and our 5 times 3 gives us our 15. So it does work. Time for practice problems. So when you see the problem, pause the video, work it out, and then press play to check your answer. First problem. All right, so first of all, we do have to know it's a 30, 60, 90 triangle. If you do triangle equals 180, the missing angle is 60 degrees. And so if the short leg is x, that means the hypotenuse is 2x, and the y would be x radical 3. So this one's pretty quick and easy. If 2x is 50, that means x is 25. And if x is 25, then y is 25 radical 3. Next problem. Okay, since this is an isosceles right triangle, those two angles would have to be 45 degrees. So it's a 45, 45, 90 triangle. And if we use x for our leg up there, that means our hypotenuse is x radical 2. This is the one that's a little harder to do. You set up x radical 2 equals 64, divide by radical 2. But then when you simplify by multiplying by radical 2 over radical 2, you get 64 radical 2 over 2. And the 64 divided by 2 can be simplified. X is 32 radical 2. And y is going to be the same thing, 32 radical 2. Okay, next problem. Go ahead and pause it. All right, once again, if you want to prove that you have a 30, 60, 90 triangle, triangle equals 180 would lead to a 30-degree angle on that missing angle. This time our long leg is 9 radical 3. That's exactly what we want to see. So if the short leg is y, then 9 radical 3 needs to be y radical 3. So if y radical 3 equals 9 radical 3, and the hypotenuse is 2y, the y would be 9. And then to get your x, your hypotenuse, you just double it and get 18. Next problem. All right, we're missing a right angle here, but since the other two angles are 45 degrees, the missing angle would be 90. All right, this one's another quick, easy problem. It follows our pattern. If we let the 19 equal n, then the y is equal to n, and the x is equal to n radical 2. So x is 19 radical 2, and y is simply 19. All right, last problem. Okay, this one, our short leg is the x, which means our 16 would be x radical 3. Also, we have the right angle on the bottom when we do triangle equals 180. So we don't have what we like to get. It takes a little longer. So we set up x radical 3 equals 16, divide by radical 3, and then we want to simplify. X is equal to 16 over radical 3, multiply by radical 3 over radical 3. This time we get 16 radical 3 over 3, and you can't simplify further than that, so that is your answer for x. To get your y, your hypotenuse, you have to double that. So y is equal to 32 radical 3 over 3.